Thought I would make a quick video on a cooking system I'm working on out of mostly recycled materials, trying to make it as lightweight as possible but still get maximum heat. This is all just prototype, so there could be a lot of changes that happen. Right now I have this pressurized alcohol stove, sometimes referred to as an atomizer stove. You remove this bolt and pour alcohol in there, denatured alcohol, which I've already done, and it has a little pan for underneath it that you put a little alcohol on to light, and that primes, that heats up the alcohol stove, primes it essentially so that the alcohol start coming out of these little jets and it will light. I have a homemade Calder cone here made out of aluminum flashing. I have decided to go with a very simple pot rest that is just a piece of wire hanger that goes through the cone. This, first of all, is just lightweight and easy. Second of all, I think I'm going to add extra holes to allow the height of the pot to be adjusted, though I'm not sure it will make a difference. It'll have to be something that's tested. And this is just a can from Campbell's Thick and Chunky Soup that fits inside the cone like so. It sits crooked a little bit to one side, always because of the rest is just a single piece of wire, but I don't think that's a big deal. So far it hasn't seemed to be. You light this stove by lighting the fuel on the primer pan. It heat up the stove, and light and as fuel vaporizes in the stove, it will light the vapors coming out. We'll try and speed up the process just a little bit by using the lighter to light the fuel a little bit earlier. And actually, I don't think that's even going to make a difference, because there it goes on its own. It's going to start lighting on its own. Okay. Now the fuel on the pan will burn off shortly, and we'll be left with just the jets. The jets will also kind of calm down and become a lot more, just basically the same jet all the way around. But as long as the fuel is on the pan still, it affects the jets. So then, simply just take Calder cone with the pot and put it over the stove. And we have some air holes down here. And if we look down inside, we can see the flame. To add some light here. Water goes a little less than halfway up the can, and the water level sits just below the level of the cone. So all the heat goes past the water before it leaves the cooking system. And let's see if we can see some more flame down in there. And already the water's starting to bubble, and it heats up pretty quick. Just for the sake of seeing how this system works, we'll pull the can off. I usually just use a little lightweight Teflon pot holder for that. And there's the flame inside, and it's hot. You can feel the heat 2 feet above the Calder cone, easy enough. So this is the current kind of system I have going, and so far it seems to be working pretty good. And some more testing and adjusting, I think we'll have a Really legitimate system. It boils the water within a couple of minutes of the stove jets starting to burn, between 2 and 3 minutes. It takes about a little under a minute for the stove jets to start burning after you've lit the fuel on the pan. So in about 4 minutes from when you first light the system, you have boiling water. And it will boil for another 4+ minutes, depending on how much fuel you've put in the stove. And that's it so far.